All right, this is 4.5, day 2, part 2. The second example. I threw a little bit more pieces to this function. So we're going to go and answer all of the pieces first and then graph it at the end. So we're graphing f of x equals negative 3 cosine of 2 pi x plus 4 pi. So what is my a value? What's my a? Negative 3. So what does my amplitude look like then? 3, that's the value of a. Give us 3. What's my b value? Yep, right here. This is my b value. So 2 pi. So then I have to find the period. How do you find the period? 2 pi over b. So 2 pi over 2 pi is 1. So it takes, okay, I lost my connection. 1 radian for a revolution. Is there any vertical translations, up and down? Any d? No, our d would occur on that back side of the equation or way in the front if they try to trick you a little bit. What about horizontal? Now there is, yes, there's that parentheses going on there. So there is a horizontal translation. What about reflection? Is there a reflection? Yes, that negative. All right. So the last piece is to go and find out where do we start our revolution, where do we stop our revolution. So we're going to use this parentheses right here. So we're taking this parentheses and it's replacing our bx minus c. And now what you do with both of those equations is you solve them for x. All right, so over the left endpoint, the left equation, what do we want to move first to solve it for x? Subtract 4 pi, good. So 2 pi x equals negative 4 pi. Then what do we need to do?
Wait, why would it be plus?
You just said that doesn't, this, you can kind of ignore that. It's just, this piece right here is always your parentheses in your equation. So if you want it to be plus or minus so it doesn't confuse you, you can do that too. The textbook uses bx minus c. All right. What will be the next thing to solve this for x? Divide by 2 pi. So negative 4 pi divided by 2 pi. The pi's are going to cancel. And then negative 4 divided by 2 is negative 2 radians. So our left endpoint, we're going to start on the x-axis, negative 2 radians. Now let's come over to the right endpoint, where we're going to stop this revolution at. So we, again, solve this equation for x. So what should we do first? Trying to get x by itself. Subtract 4 pi. So 2 pi x. 2 pi minus 4 pi is negative 2 pi. And then we divide by 2 pi again like we did on the left equation. Negative 2 pi divided by 2 pi 2's cancels, pi's cancel, and we're left with -1 radian. All right, now let's go and graph it. So what was our amplitude? 3. Okay, so we're going to go 3 up, 3 down, and our left endpoint on the x-axis is -2 radians. So we're going to go to the left. So here's -1 radian, here's -2 radians. Now we're going to split our x-axis from -2 to -1 into 4 equal parts. So I might want to make this go out a little farther because we're dealing with some decimal places. I'm just going to make it really big. So let's have this be -2 way out here, and this be -1, just so I'm a big writer. So now we split up into 4 equal parts. What's the halfway point between -2 and -1? -1.5. And then halfway again. -1.75. -1.25. All right. This is a cosine function. Cosine functions start at the top of the amplitude. But we have a reflection, so they're going to start where? At the bottom. So down here is the bottom of the amplitude. Now we do our pattern. Middle, top, middle, bottom, where we started. And that's 1 revolution. All right, don't need to write anything on these next slides down, just kind of listen. Here are some examples of why we use sines and cosine functions. We talked about the ocean and the ocean waves mirroring our sine and cosine functions. Here's some more. Temperatures, tidal variation, phase of the moon, animal population. So here's just a quick example. Let's say that Cape Town, Africa, these are the temperatures in a 12-month period. If they go out and graph those, does that look like a sine or cosine function? Yep. Then they organized it. 1 month represents January, 2 months represents February, and they just graphed it as such. Another thing we can talk about is high tide and low tide of this example in Alaska. So they go out and they watch day 1, day 2, high tide, low tide, and they started to graph them. Here's what the graph looks like. Does that look like a sine or cosine function? Can you tell where the highest peaks are, the highest tides? Those are your maximum points. So there would be a maximum. These would be your minimums. And then they can go through and talk about what does that mean. You can write an equation for it. In this case, they were writing a sine function. So they took all the pieces and they plugged the pieces back in to write a sine function for that. And then they can go out if they want to make predictions about it. So this was their sine function when they were done. That. Let's go on to your assignment. Day 2. There are some types of problems that don't have the horizontal translation. That's fine. I'm still keeping some of the problems that we covered on the last lesson.